Right. So you're most welcome, Mr. Elimo. Hopefully you can hear me. Okay, and yeah, welcome everyone. Manuel, Aaron. Yeah. So today we are going to be continuing from smart contracts. Let me share with my screen. And okay, so hopefully this will now show well. Okay. Yeah, so we usually don't know. We usually ask ourselves, as someone asked yesterday, how do we use these smart contracts, or how are we going to be using them? So, and if I can get an online sketch, sketch up. If you have any suggestions of tool I can use to sketch online, you can share. But other than that, oh, this is the way the smart contracts work is simply they work like the back end of our product. So just imagine you, or even don't imagine, but you want to do transactions that are immutable, or you want to write code that is transparent, that can have public scrutiny, and then what you say your code does is actually what it does. In this, it means that you cannot change your code. And that means that if you try to change your code, for example, if you have a Web2 platform and you want to change maybe the way the rows are stored in a database, you can actually tweak your code and make those changes. But in case of Web3, if you try to change what you've already deployed, you have to redeploy a new one. So that means that users can trust your code by viewing the code itself and having the address, the contract address of the deployed code. So that means that you will not say that I deployed something wrong, then I want to change it. So that means that if you want to change it, you will have to redeploy a new thing, and then to be able the community to interact with your smart contract. Though there are some other things like upgradable smart contracts, but that's the fundamental. And we are going to be looking into all these. So the picture should be that you can create a web app, maybe a front end that talks to a blockchain, transactions, moving data, cryptographic proofs, and maybe it's decentralized identity, privacy, and things like that. Then the way that this front end will talk to the blockchain is through a smart contract. And as of today, we are going to look in some depth about the smart contracts. My aim is to make sure that we can cover some of the things. Smart contracts. Okay. Probably I should look at solidity. Solidity smart contracts. Or even I can go to sesseion and look at some of the smart contracts. So my aim today is to make sure that we cover these smart contracts, how they are built, and as we move deeper and deeper, then we can create and also create front ends, and then have these smart contracts interact through libraries like VM. Yes, so in any case, if you have any questions and anything as we move on, you can always put it up. So when I come to sesseion, so this is a block explorer. A block explorer is is where you go to see all the transactions that are happening on that blockchain. So Sepolia Scam is the test network for Sepolia is the test network for Ethereum blockchain, and then Sepolia Etherscan is an explorer, a block explorer for the Sepolia testnet. So when I come to this, I can see these things that are written as a page of a book. So these are deployed smart contract, and even without writing any smart contract, I can look through, this is from this to this. I can see whether the smart contract is verified or not. So there is transactions, internal transaction, token transfer, ERC20, and NFTs. So latest ERC20 token transfer events. Okay. So these are activities that have been happening on the smart contract deployed on this address. And if I can go back, I think I can have the contract itself here. So transaction action, this is the transaction hash, status, success, then the block height, it is at this block number 11 block confirmations 2 minutes ago from this to this smart contract. Okay, so my interest is reading through some of this smart contract. So as you can see here, there is source code. So this contract's source code has been verified to match its on-chain byte, and that's good. So how do you see that a smart contract is verified? Down here after transactions, internal transactions, token, and contract events, there will be this contract tab. It will always have a tick, and as we write a smart contract, we are going to go deeper and see how we can also verify our smart contracts. Okay, just looking at this smart contract. So contract source code, solidity standard JSON input, you see file 1 of 21, and you might be surprised, how are they 21 files? So wherever you see that, there are these imports, import ERC20 from at openzeppelin contract. So this is a GitHub repository, and yeah, we are going to be also looking at it. Import this permit from at openzeppelin, import ownable from our openzeppelin contracts access ownable. So all these importations, when the contract is being verified, are sort of brought as the normal files are brought as part of the smart contract, so that everything is in one place. So if we had to look at this is a contract. USDC is ERC20 ownable, ERC20 permit. You may not know what all that means, but it simply means we have the contract, as we said yesterday, that when we are declaring our smart contract, we start with the contract keyword and then the contract name. So the contract name here is USDC, and yeah, stands for inheriting. So it inherits this ERC20 smart contract, it inherits the ownable smart contract and the ERC20 permit. And also, as we are seeing right here, is that we have imported these smart contracts from wherever they are. Okay, so in here we have some functions. We have a mapping. We are going to look at it. We have a constructor. We have another function of decimals. We have function facet. So yeah, we looked at function. So we have the function and then the function name, and the function and function name and other words. Then there is some logic in it. So you will see that right here, file 2 of 21 is ownable.sol. This simply means that the ownable that was imported has been brought here so that everything can be verified, and also it helps that that exact version is the one that is inherited. So the exact version of 0.8.20 and above. Okay, but also ownable imports this context. So that context will be one of the smart contract files that will be here. ERC20 permit, we've seen it. And yeah, you can actually always look into the smart contracts. This is one of the things that we are really going to also be doing. I think we shall always come back to the smart contract. This is a USDC deployed smart contract, and we are going to be iterating and seeing how this comes about and more in that. So we have looked at openzeppelin. If we are to look at openzeppelin for a short while, so there's a platform called openzeppelin wizard. Which can help you write smart contracts quickly. My personal advice would be that yes, you can use it to write smart contracts, but always make sure that you know what you are writing, because smart contracts really hold a lot of value. And if you just use AI alone, or just this wizard alone without knowing what exactly you're doing, one it's not even one line, but one word can lead to exploits. Yeah. So openzeppelin can help you to bootstrap smart contract. All you need to do is to come to openzeppelin. So let's say you want an ERC20, an ERC721. I know we might be asking, what is ERC? What is if you want a stablecoin smart contract, yield asset smart contract, account governor smart contract, and a custom smart contract that is just yours. You can just click on what you want, and then just keep ticking here, and the smart contract is writing itself. And afterwards you can just copy and and paste and then deploy. Okay. So as we are still here on openzeppelin, we are seeing actually we also have Cairo. So if you are deploying smart contracts on Stacknet, we have confidential. If you are doing confidential compute, I think these are some confidential smart contracts. If you are deploying smart contracts on Polkadot, and as we saw, one of the hackathons that we have at openzeppelin is a solidity or EVM smart contracts and building products on the Polkadot ecosystem. So Stellar, Stylus, if you are doing a Bitram, and then Uniswap hook. So if you are building a hook, and you want to do something, I think I will really come here and write my hook from here. Okay, have a hookathon. So I think this is Uniswap hook v4, if I'm not mistaken. All right, so we go back to Solidity. Just as we are looking into this smart contract, so one of the things is always not to get intimidated, because we are already in depth. So an ERC20, most of the tokens that are on the Ethereum network are ERC20 tokens, and some of the examples of ERC20 tokens include stable coins and many other tokens that you trade on platforms, on decentralized exchanges and other platforms. So if you've traded some token on platforms like GMX, if you have some token in maybe somewhere on a centralized exchange, it could be an ERC20. And for a token to be ERC20, the reason why we say it's ERC20 is because it conforms to the ERC20 standards, and we shall look at those in detail. But for now, let's just create an ERC20 token and at least deploy something to go through that. So I'm going to name my token name is this fantastic token. So and then the symbol will be maybe FNT. This is going to be my token. So pre-mint, I have no pre-mint. Mintable, that means that, you know, so wherever I write something, the changes are made here. So if it is mintable, that means that I can mint more of it. So when I click on the mintable, the constructor and then the function to mint already populate the canvas. Bannable, permit, flash minting. I think I'm going to just have that. And then I have an initial pre-mint of maybe, let me say, 10,000 tokens. So you can see that when I mean 10,000 tokens, it is multiplied by 10 to power decimals. And this decimal is actually 18. So we are going to look and see where this decimal, but it is actually 10 power exponent 18. And the reason why it is 18 is because the virtual machine is written with many decimal places. Specifically, 1 is equal to 1 power 18 way, and way is the smallest unit so of Ethereum. So that means that if I want to mint 10,000 of my tokens, I'll mint 10,000 times 10 to power 18. And simply by that, I already now have a token that is, I already have the code of a token that, you know, I can deploy. So let's go on and deploy this. For me to deploy, I can click here to copy. You can also just open in Remix, or you can download the source code. So I'm going to copy because I'm going to use another platform, another search engine, Brave, to deploy. And yeah, here I have very many smart contracts. So what I'm going to do is create a new folder, and I'm going to name it, I think I can create new folder, import, okay, yeah, let me just create a new folder and see. I think today is sessions solidity. So if you missed yesterday's session, or you want a recap, you can find those on the Central Code channel. Let me see if I can. Okay, so here, if I go to the Central Code, so these sessions have been going on, and so today's session, yesterday's session was uploaded, and you can also simply go to the playlist if you want to view all the sessions for this cohort. You want a recap, and then I think this is the playlist for this cohort. So also you can subscribe and then keep watching this content, and so that's it. So hopefully I'm recording, okay. So yesterday's session we simply broke the ice, and the session is right here, and let me just rename this as sessions. So sessions solidity, okay. So in here I'm going to create a new smart contract, and I've called it fantastic.sol. So let me really have a lot of solidity files. Oh, these are many. Okay, so okay, so we have fantastic.sol, and with this we can copy our code and paste it here. So Remix will have, say we've just posted code snippet or contract in the editor. Make sure you fully understand this code before deploying or interacting with it. Don't get scammed. Running untrusted code can put your wallet at risk. In a worst case scenario, you could lose all your money. If you don't fully understand it, please don't run this code. If you are not a smart contract developer, ask someone you trust who has the skills to determine if the code is safe to use. So we know that openzeppelin are some of the most audited companies in the ecosystem, and we can trust that code. So with simply with these 21 smart contracts, you have a token to deploy. Okay, so as we said, if you're in Remix and you come, after that you can come to the Solidity compiler. If this is already on auto compile, that means that your code will compile automatically, and mine is also on auto compile, but you can also recompile it just to be sure. And then we are going to deploy. Oh my god, I have very many smart contracts. So here, make sure that you're on the fantastic sessions and then fantastic.sol, and yeah, so this is my smart contract. And for me to deploy this on the Sepolia test network, I have to change this environment and choose browser extension, injected provider, MetaMask. So once I put that, you see that now it shows the Sepolia network 111.55.111 network. And if it doesn't show you the Sepolia network, all you have to do is to come to your MetaMask wallet. If you're one of those who don't have a MetaMask wallet, I encourage you to just go to MetaMask wallet extension, and you will have it. MetaMask wallet extension. Just right there, MetaMask download Chrome Web Store. So if you're doing the smart contract, I believe you're doing it on a machine, on a computer. So you can go to this link, which has the Chrome extension, and yeah, can click on it. I think we have a session where we installed MetaMask. All I can say with this is don't share your keys. Don't share your seed phrase. So your phrases, you must keep them to yourself. Write them on a piece of a paper. Write them somewhere. Don't save them online. And because your keys is actually the actual wallet, your seed phrase is the actual wallet, the entire wallet, and your private keys is the account, is the access to a given account in your address. And what I mean is that if you have your seed phrase, you can access all the accounts. So if you look here, I have 1, 2, 3, 4 accounts. So if I have my seed phrase, or if I stored my seed phrase somewhere, I can simply use my seed phrase on another computer, on another device, and retrieve all the accounts on my MetaMask wallet. And if I have the private key of this, so the private key can only be a key for an account. Let me say I have a private key for this account. That means that I can access the assets, whether they're NFTs, whether it's tokens, on that account in that MetaMask wallet. Okay, so make sure you have one. And so for you to deploy, you have to come here on your MetaMask. Okay, still a Arbitrum Sepolia, and change here to you go to custom and look for Sepolia. So my Sepolia is down here, and I have some ETH on my Sepolia network. And yes, after that, if again you're not seeing it, you come here to the icon of the remix. So I think it is the second right icon. Whatever website you connect to your MetaMask, it will come here. So you click on that icon and say manage permission, and then here you edit. So edit, and then for me, you tick only Sepolia. So sometimes you can come here and all networks are ticked, are selected, and wherever you try to write injected provider, it does not connect to the Sepolia network, the network that you want to deploy to. So you come here, you deselect everything, and you make sure that you have only Sepolia selected, and you update. Yes, that's it. The other tip to really keep your account safe is always to go to settings, to go to these three, this button here, the top right button, and lock your wallet so that wherever you come to open your wallet, it is locked. So let me give you an example. My wallet is not locked, so if someone has access to my computer, they can come and click on my MetaMask, and boom, my MetaMask wallet just opens up. At this time, if they really have more time, someone can just come and say, hey, I need Sepolia, let me just send. So here there is swap, send, receive, and somebody puts, let me send, I want to send Ethereum, I want to send on Sepolia, so I want to send some Sepolia, and then they put their address and the amount and they send. So for me to be safe, always whenever I'm done, I have to come here and lock my wallet, so that the next time I come to open this wallet and I click on the wallet, I will be prompted to put in my password. This is really very crucial because you're going to go into meetups, and people will have access to your computer in some way or the other. So someone can drain your wallet by simply social engineering and things like that. Okay. So if you have your MetaMask wallet, there are very many faucets you can go to. I think some people would help us even share links to facets where people can go and get testnet tokens on Sepolia test network. If you fail to get testnet tokens, maybe sometimes because your wallet is new or something, you could always, chat us somewhere in the central code channels. I think one that is very much used is the Telegram channel and the WhatsApp channel for the cohort. So yeah, if you're not in Telegram, simply go to Telegram. There is always the central code in cohort 2. Yeah, you can always say I need some testnet tokens, and paste your address, and yeah, there'll be very many other builders more than willing to help or give assistance, something or anything that is needed. So after that, we are going to deploy our first smart contract, which is an ERC20 token. So we are going to have a token on the test network. So the test network doesn't have real tokens. So all this Sepolia ETH has no real value, but it can be used on the test network to test before we go to a main network. So have put injected provider, and Right down here, there is verify contract on explorers, but there's also deploy. So here there is deploy, and then there is address recipient, and then initial owner. So the recipient. So here when I was on openzeppelin, I said do a pre-mint. So whenever you're minting tokens, you mint them to an address. So and here in the constructor, there is ownable, because the smart contract, there should be somebody owning who has rights over the minting of these tokens. And yeah, so that is it for this one. Maybe if you remove some of the things, and then so we need the address of the person who is going to receive the first mint, who is going to receive part of the first tokens, and also the address of the person who will be owning the smart contract. Okay. Owning the smart contract means that you have you can access, you can interact with the functions as an admin of the smart contract. So for now, I'm going to use my own wallet as the initial owner. So if there's someone who wants to receive some of part of my tokens, maybe you want to be part of the recipients of my tokens in your wallet, you can share your wallet address in the chat or something like that. Otherwise, so I'm going to be the first recipient, and initial owner, it's again going to be my address. And when I click on transact, so this was like this, and I wrote it like this. So when I click on transact, then the smart contracts gets deployed. And as you can see, my MetaMask address has popped up for me to sign on this transaction. I have to click on confirm and back, pending, and then view on Etherscan. So my smart contract has been deployed. This is the contract address. And down here, when you look at the deployed contracts, we have fantastic at this address. So I can view this on sesseion. So this is the testnet, and we can see the transaction hash from, you can see from my account 2FA, and when you look at my wallet address, it ends in 2FA, and here they successfully, and gas and everything. So this smart contract has been deployed. You can also look at the logs. Previous owner, new owner, view store, topic 0. These are also very, very crucial as you become more acquainted in smart contracts. You see that you'll be interacting a lot with your logs. So we also have state, producer, nonce 74, and so we have all these details. Mind you, our smart contract is not verified, but we can see everything that we can see. Sometimes if you can't see your smart contract, you can come and copy your address. So this is the address of the deployed smart contract, and then search it on the Sesseion if you've deployed the smart contract on Sesseion. If it is on Etherscan, you put your address on Etherscan. If it is on any other blockchain, and we can look at transactions, token transfers, ERC20, and then when I look at contract, because my contract is not verified, all we can see is a bunch of bytecode, and that's it. Okay. So I want to share some of these smart contracts. So if I want to see these tokens in my wallet, let's say we created a meme token, meme coin, and or even not a meme coin, but we have our own token and it has utility. Maybe it's one of the things we use to access a product. So if I want to see it in my wallet, all I do is go to that chain. So, and in this case, it is Sepolia. I go to Sepolia and make sure that I'm on the Sepolia network. Then on the right side of the chain itself, there are 3 dots, and then there are 3 dots and 3 dashes. So on the top, on the most right, on the 3 dots, there is import tokens, and the network is Sepolia. Token contract address, you use that address that you've used for deploying. And as soon as I put the contract address, you can even see the symbol. And when I click next, it will show that the amount that I have. So I have 10,000 FNT, which is the fantastic token. So I can import, and here token fully imported. And right here, you can see this token showing up. So with just what we have learned, you have the power to create your own token. The tokenomics and other things can be seen later, but actually you can create your own token even on the main network. And people trade it, and then it gets on exchanges, and maybe it is used as a utility, and you can create an entire business out of the capability of blockchains. So if you are one of the people and you want to receive part of FNT token that I've created, just share your wallet in the Google Meet. Let me check if someone shared anything in the Telegram. This is very, very powerful. So someone was asking the power of smart contracts. We are just on the tip of the iceberg. I think there is really nothing. So, yes. Let me see if we have something in here. Okay, feel free to share your address. Maybe we can play around with this token that I've just created. Who knows, you can be part of the rich people owning my own token, having a part of a pre-sale. So this is getting slow, so I encourage you to always to paste in the chat. So now, as we've said, you have the token FNT, and you can probably have a shop where people can buy your token. You could list it, you can have daily data, and then go into all those tokenomics, have your token grow in value and things like that. So this is one of the things that is really, really amazing. One of the tokens that I think we saw yesterday was IMU, a token by Immunify. So they created and minted some tokens on the main network. When you look, let me see. Let me say all accounts, all popular networks. This is a test network. But if I look closely, I have some other tokens on Lisk Sepolia testnet. I have this 0.22 ETH. So you can have your own minted token and display it or use it for other purposes. Any questions so far? Okay. Yes, is there some question? Okay. Yes. All right. Yeah, thank you for that question. So, how does it really work? So, everything depends on your logic. And for the logic that we have for this ERC20 token, is that we want it to be mintable. That means that I can mint other quantities of this token. You see things like, for example, USDT. USDT can be mintable if you have the right to mint those stable tokens. You can mint USDC and things like that. But you can choose that you have a steady supply, and as soon as you deploy that smart contract, that means that that is the only number that will ever exist. Now, for the sake of Bitcoin, the program was created in a way that uh, only 21 million Bitcoins will ever be created unless the entire community comes in consensus to create more Bitcoin. Yeah, but only 21 million, and every 4 years, I think that's the cycle. There's halving that happens. Halving simply means that the rewards that we are given to the miners. So the miners are these people that are making sure that the blockchain is safe and it's decentralized. So wherever someone suggests, wherever there is a block is created, so there is mining of that block, and computation power is used to solve a challenge that has been created, and the miner or the node or the connected computer that solves that challenge first is given rewards. So every 4 years, those rewards they break down into a half, or they are reduced into a half, and that's what we call halving. But until time immemorial, or in case the community chooses otherwise, the system was set in a way that 21 million Bitcoins will be traded, will be created in circulation. Yeah. So that's it about Bitcoin. Now about trading. Trading is its own economic world. The fundamental could be that the more that people have faith in your token, that means that the more they are buying it, the more your token is gaining value. Let's say I minted 10,000 of my token, and I said we shall not mint anymore, and all the people who are holding the token have great belief in the token. So other people, whenever other people come in and keep buying from those that hold the token, actually the value of the token goes up because new liquidity has come in, or new cash has come in, and those are the tokenomics about trade. So people can always track how the token is working, because all this data is on the blockchain. So I hope I've answered those concerns well. Otherwise, if there's someone who wants to add on, you are most welcome to. Okay. welcome. So I can actually send some of these tokens to my other wallets. Let me see if I can get this address. Okay, so I have an Ethereum address. So I can is there someone who has okay, yes, someone has okay, so this is Aaron. I'm going to use Aaron's address and send him some of FNT tokens. So if I click send to and amount, I can send him 100. Okay, so confirm pending. Confirmed. So I've sent 100 to Aaron. For you to see these tokens in your smart contract, in your wallet, you have to import the token address. So let me share the token address here. So you will simply go to your wallet, and make sure you have, and make sure that you are on the under here where there are tokens. You come and click on tokens and make sure that you are under the Sepolia test network. So right there on these three dots, you import tokens, and then when you import that, the address, you see actually those amounts of token in your wallet. So this is actually how we send USDT, USDC on a given blockchain. Yes. Pardon. So are you on the Sepolia network? You could also share your screen if you are okay with it, or I can go through it again. So once I'm on your wallet address, you might be on the Ethereum network. So most of the time when you get your wallet address, it always be on the Ethereum network. So you always have to come down here. These days the MetaMask was changed layout. So sometimes when you come down, this tab is maybe on activity, and whenever it is on another tab, NFTs, you might not see the chain that you are on. So I usually put it on the first tab, which is tokens, and click on the chain that I am on. So Sepolia is not under the popular chains, it's a custom network. So in the custom network, under test nets, there is Sepolia. If you're not seeing it, you can add it. And how do you add it? You go to chainlist.org. So chainlist.org. And then when you're on chainlist, you tick on include testnets. So, and then you search for Sepolia. There will be base Sepolia, and what you want to connect to is Ethereum Sepolia, and then you click connect. Hopefully with that you will have added it, but you can also add it manually. And yeah. Uh, there are also other ways. So when you're on the Sepolia test network, down here, under powered by Ethereum, there is add Sepolia test network. You can click on that and also add it. I think we went through manual ways of adding the Sepolia test network to MetaMask in some of our previous sessions. Okay, Aaron, where are you? Have you seen your balance? For you to see your balance, come to your wallet and make sure that you're on the Sepolia network. So on the right, there are these 3 vertical dots. And when you click and say import, they'll ask for the token contract address. It's what you come and copy inside in the chat. So this token contract address that I shared, you come and copy it and then paste it. And yeah, for me, I've already added. Hopefully that is okay. So that's why when you look at USDC smart contracts, so USDC token smart contracts, you will see you see that they are here on the mainnet. You can see Arbitrum, this is the address. So after deploying the USDC token, then they have the address. They register those addresses right here. So in case you want to interact with that address, you just copy it and use it. Yeah. So in case I want to see my USDC on, let me say Sepolia. So on test network, there is Ethereum Sepolia. So this is the address for USDC on Ethereum Sepolia. What I can do is I can come here and under Sepolia, and then I say import token. I put the contract address, and they are saying token already added. Okay, so that means I already added this USDC. It is here. You can also get more of these USDC test tokens from the USDC test token facet. So yeah, these interactions really help you like get familiar, help you. So here, USDC, if I want to get some testnet tokens on USDC, I come here, I copy my address, and then so I'll get 20 USDC, and I have to make sure that I'm on the right network. So this is ARC testnet. I want to be on Ethereum Sepolia, and yeah, send. So I've been sent these tokens, and when I go back to my wallet and I check on USDC, could not fetch any. Yeah, so when I check, I think that it has just added now. It's 24. So I think it was indexing. So yeah, even with just smart contracts, you're seeing how far you can go and how far you can interact with most of these smart contracts. So that means that we have deployed our smart contract. If we want to interact with it, we need the contract address. In the front end, we shall use the contract address and the ABI. So, for example, even when you want to interact with support with the, let's say, USDC token, you will always come, let me get the address, and you will always come here, you have the contract address, and then get the ABI, because this contract is verified, so you can see the contract itself. And also when you look at the USDC USDC contract, you can go through their code. So they imported admin upgradability proxy, and then they have a fiat token proxy. So contract, this is a fiat token proxy, this is the library, this is the upgradability proxy is proxy, so that means that they are inheriting. And 4 out of 5 is we have abstract contract proxy, so they have a way they upgrade the admins. And we have this admin upgradability, and yeah, you can have the leverage to read through their smart contract, read through the different contracts they imported, and you can also create your smart contract likened to theirs. But my interest was that there is always a contract ABI if that smart contract is verified, which is this. And when you have the contract address and the ABI of the smart contract, then you can call many of the functions on that smart contract. So we are going to be looking at ERC20 standards have around, I think there are 5 functions and 3 events. So there's the function transfer, you can check balance even when you didn't deploy that, and other added features that maybe are specific to that smart contract. But going to our deployed one, so let me open 2 Sepolia scans. So if we also wanted to interact with, let's say, our own smart contract, we would get the contract address, and since it is not verified but we are the deployers, we can get the ABI. So ours doesn't have the tick, and here we have no verification. Maybe I can try to deploy it and verify, but even without that, we can always get the ABI if we are the deployer. When you go back to the compile, there is the ABI here. So copy ABI to clipboard. If I copy it and probably paste it somewhere, you can have a look at it. Let me just create a new file. I've copied it, and just ABI here. Let me say .json, and this is how the ABI will look like. So it's like an API, and yeah, this will give you the capacity to communicate to this smart contract from a front-end application. So that simply means that you can develop a Web2 application that will interact with your smart contract. Yeah. And that's what most of the applications do. Maybe an example can be GMX. I don't want to have many tabs. Okay, so we also have applications like AfriRamp. So this smart contract, whenever I connect my wallet and then I do prices, if I'm to buy or sell tokens from this, because this is a decentralized application, I'm actually interacting with smart contracts in the backend. And that's the beauty of it. So this is just a front end to shield me from the smart contracts that we are deployed. And the good things with such platforms, like decentralized platforms, is that you can always have the liberty to look through the smart contracts, so that the contract is doing what it promised to do, or at least you can read the code and see and check for security and things like that. Okay, yeah, so GMX contracts are open source, and yeah, this is all the power of Web3. But maybe you don't want to go those extra miles and you want to just trade. You can trade in a decentralized manner on this platform. This is not financial advice. Yeah. So this is how the ABI looks like. So with the ABI and then the smart contract address, you can always interact with that contract. Okay, so we can now go a bit in detail of how do we really build these smart contracts. So probably we could have a next session a bit. Questions are welcome. If you have any issues as we move on. Sente zijja nziraba. Huh? All right. So since we've had a small rest, hope we are still energized to move on. Now let's dive deep into what this solidity thing is. And yesterday we looked at our primitive data types, and I'm going to just make a small recap. So we are going to go further. We are in sessions. So we looked at primitive data types. I think here I had sessions, fantastic.sol. So new file, recap. Yeah. So among the primitive data types, we had Boolean, where you can say bool something. We had u into 56. We had int, so it can be int 8 up to int 256. So int 256. And then we also have the address. So let's just have our smart contract, SPDX license. Identifier MIT, pragma solidity, the caret maybe 0.8.26. So that means that we are compiling from that version onwards. And then contract name can be recap. And yeah, so in here, so if we declare a variable outside of function, it is known as a state variable. So we had local variable, state variables, and global variables. So we said global variables are those variables that are in the smart contract, like msg.sender, msg.value, things like that. Block.timestamp. So if I say bool did he come, so Boolean, the variable name, the name is that did he come. So you want to know whether this is true or false, and then public. So public is always first. Public, did he come? And yesterday we said if a Boolean has not been initialized, it is by default false. So by default here the initialization is to false. Initialized to false. So we are going to today simply look at go a bit deeper and look at some of the things, then use them in implementing probably a smart contract as we go further and until we start having our smart contracts, interacting with front ends and other backends as well. So I can have uint 256. This is good. Public age 25. We have int public degrees assigned to -180 or -5. So this can be negative or positive, ranging from 2 to the power 128 to -2 to the power 128, whereas this here ranges from 0 to 2 power 256, but here it ranges from -2 power 128 to 2 to the power of 128. So you can have address public owner my address. So this keeps no public my address. This keeps the address of this keeps an address, whether a smart contract address of a deployed smart contract, or the address of an externally owned account like your MetaMask account. So all these declared variables are state variables, and the reason they are called state variables is because they are declared outside of functions. And changing these variables requires writing to the smart contract. Okay. So with this, we can look at other things like specifiers. We have looked at them. Specifiers. I think before we go there, we can look at visibility. So the way we write smart contract, so visibility, we always have 4 visibility, they're called visibility specifiers or visibility modifiers, but they are for visibility. We have public, private, internal, and external, and these are very crucial. So when you see some of our declared variables, we have both public this. If I save this and then I deploy this, so for me not to always be disturbing or wasting my own tokens, I'm going to be deploying to a virtual testnet by Remix virtual machine, and Osaka, and so if I deploy just this as a recap, you can see that age is visible here, degrees, did he come. So if I click on the did he come sort of button, let me say, to return false. We said by default if it is not initialized, it always returns false. And then we have my address, there is always nothing, so the default address is the 0 address. And degrees, if I click on it, the initialized degrees and the age will be returned. So with public, public visibility, I think the specifiers are always accessible within a contract and externally and outside of that contract. So in other words, any contract can call any contract or externally owned account. So in this we are connected to this account. So Remix VM gives us an account with 100 ETH, and we used some ETH during deployment, but I am calling these variables using this account, and I'm calling them from this deployed smart contract. But you can also, since they are just like for viewing, you can also call them without having any account. just by calling them. So the best way could be any contract, all external on the account, and account can call this, so public visibility, but public specifiers can call this. Hopefully this is okay. So probably if we want to have this, I can just have a function and I say get address, I give it an address, a DDR, and public view returns. So here I have return, warning function state mutability can be restricted to pure. Even before, let me just set the address. And I just say public and I say the address app is assigned to the given address. So this address is called my address, okay? Yeah. So with public, I can access this function because of the public visibility specifier. I can access it. So if and then since it is just public, so this is a function called setAddress that is accepting an address and it is being stored in this local variable ADDR. So these ones are called function arguments. Are they called arguments? Yeah, arguments. And then we have the public, so it's just a public function. And since we are going to change the state, that means that we are going to spend gas writing to this address. Okay. So if I save this again, Control S, or you can come here and compile, and then deploy it again. Here they show you that down you've deployed recap constructor, value data, and here this is the new deployed. So within here there is set address, and right now when I click on my address it is 0, but when I set it, let me just set any address. Let me copy this as the address that I will want to set. So when I click on transact, it's actually going to write on the blockchain because I'm changing the state. The state are these variables that are outside of the functions. So wherever you change any value on those variables, you're actually changing something on the blockchain. And yeah, so even here, if we are close, we can see we have 99.999990432 ETH. So, but when we do click on this transaction, we see even mined bug, you can see one transaction mined and executed, transaction hash block from to transaction cost 4079 gas, execution cost 22, output decoded there and things. So there has been gas that has been spent, and when I come back here, it is 99, now 8 something. So some gas has been spent because we have been writing on the blockchain. But so now if I click on my address, you can see the new address. We can also always write a get function. Yeah. So here we shall have public view, and then to just return an address. So I think before we go there, we can explain these and complete them. Private, so if a function is named private, it means that only inside the contract can that function be accessed. So so if I say even variables can be private, but variables cannot be external. Variables can be private, internal, but they cannot be external. But we can have external functions. So for example, if I say bool private, did he come? And I save, and then I deploy again. I deploy again, so this is my new deployment. If you look closely, did he come is not accessible outside of the smart contract. It is not even visible here. But then a function in here can access this did he come. Yeah, so that means that, with a private, only inside the contract that defines that the function, can a private variable or a private function be accessed. Yeah. Yet with our previous deployments, you can see that the did come is one of the accessible state variables. So that means that when you declare it private, it cannot be accessed outside of that function. Okay. So if a function is declared defines that function or variable. So internal can be accessed by a contract inheriting that function. So the difference between a private function and an internal function is that an internal function can be accessed by another contract that is inheriting that function. But a private function can be accessed inside that smart contract, either by the variables or by other functions that are inside that smart contract. And external is always accessed externally. External are always functions. Yes, please. Okay, so when a function is declared public, like this, so function name, arguments public, that means that that function will be visible by external callers, external calling accounts, and will also be visible to that smart contract functions and variables. So when a function is declared private, that means that it is accessible to the variables and functions within that smart contract, but not outside of that smart contract. So even if this private bool private, did he come here, is private, I can always access it here. Maybe let me say, did he come here, is assigned to true. So initially it is false, but here in this function, I can access it and assign it to true. Yes. So if a variable is internal, so we said variables can be public, private, internal, but cannot be external. But functions can be public, private, internal, and external. So if a function or a variable is internal, that means that it can be accessed by a smart contract inheriting it. So we shall look at smart contract inheritance as time comes. So maybe if you have a function that you want only to access from another smart contract, but you don't want it to be visible to external accounts, or you don't want it to be accessed maybe from other front ends that access public functions to do manipulations on the blockchain, you can name it internal. So external, they are functions first of all, and they are always called outside of that smart contract. So these functions can be called from other smart contracts, or they can be called from other externally owned accounts. The difference between a smart contract and an externally owned account is that a smart contract is deployed, so it's a piece of code that is deployed. So, and to access that smart contract, you use its address. Like these are the different addresses of these smart contracts. That's why we say that smart contracts are not changeable. If I change something in this smart contract, I have to redeploy it, and redeploying means I create a new smart contract. So an external owned account is the address of your account. Could be the MetaMask address. It could be the Rabbi address, Phantom, whatever wallet that you have. Okay. But as we have been defining these functions, so these functions, if you look closer, they are as if they look similar to the JavaScript functions. But as we are defining them, we saw that for get address, we are using public view. So view and public, view and poor, not and pure. I used also to add I also used to so for visibility, these are the visibilities. These are, I think they are called specifiers. I don't know. They used to specify whether a function is going to change the state or it's not going to change the state of the blockchain. And what I mean by the state, so when I declare this function public view, I mean it means that I'm going to read the state, and reading the state is reading these variables, but I'm actually not going to change. Yeah, I'm not going to change anything from the state. So that function, if it is called, those are the functions that you can use to get the balance on an address, balance in a smart contract. They will simply read the state of the blockchain. So here I just wanted to get the address. I think I was get address. So return. We are going to return my address. So, and if I compile this, it auto compiles, and I deploy this smart contract. So deploy. So it has been deployed, and when I look at this now, I have get address. So when I click on get address, it will read the value of my address variable, and initially the default address is there, but then if I set this value to a new address, and setting this to a new address is calling the set address function, which is just public and can change the state of this variable. So I'm going to give it this address of mine. It's ending in 2FA. So, and you can always, you can even just put it here, and you click set address, or you can make the thing big and you add there. So it has changed the state, and if I used injected MetaMask provider, all that would be written on my smart contract as it is written on the VM smart contract. So if I click on get address again, you see that it always reads the value of the state variable. So here I can return anything. So in our function, a function has parts. It has the function name, here where you put the function arguments, and then the visibility specifiers, which we have public, private, internal, external, and then we have these types of functions. You can have this, you can have it, or you may not have it. So when I use the view keyword, I can read state variables, the value of the state variables, but I cannot change those values. So here I can even have my own, I can even do some computation in this function. Maybe I have some values that I'm bringing to this function, and I do some computation, but but the output of that computation does not change the state of the blockchain. And then this is just to return an address. The reason why I'm returning this address is because I want to view it. Yeah. But you can also have pure functions. So that would be like let me just say add. So if I just write uint, it is automatically taken as uint 256 and uint y. They say public pure returns. I want it to return a sum, so it's going to return a uint. So when I use the returns keyword, means I'm expecting something to be returned after doing a manipulation. So I can say uint 256 or even uint sum will be assigned to x plus y, and so I can return sum because I have to return something. So you can ask me, why are you putting these variables? So when I put these arguments here in the function, they will be input externally. Maybe there is someone who will externally provide x and y. So if I compile this, I'll finish compiling, and then I deploy. Down here shows that it has deployed, and here I have add. So the add function, x, if I put 2 and y as 3 and I click call, you see that it has returned a value of 5, but it is not reading anything from the state. So you can also look at this, that there is execution cost 1004 gas, but cost only applies when called by a contract. So this will only apply when called by another contract. So that means that actually, because it is not changing the state, there's nothing being written on chain, and the cost is not there. So yeah, I think those are the most things that you will see in a function. Function name, you come across public, external, and internal, and private, and then you come across these specifiers of view and pure. View is used when you want to read the state. Maybe you want to read some variable from this declared variable, but you are not going to change it. But pure is used when you are not going to read anything from the state, but you're going to do your things inside that function. Okay, so it's 19. So we can continue a bit. I think some of the things I want to cover. So things like if else are similar to those in JavaScript, but with smart contracts we are always conscious of gas, and I think we shall have that as a topic in itself when we are sober. So we also have another specifier called payable. So if a function is called payable, all an address is payable. So if I put here a public public payable, expected identifier but got payable. So let me just say so with this function called receive external we've looked at it. So that means that someone outside of the smart contract, either another smart contract or an external owned account, can call this function. When the function is payable, even without anything in the function, that means that this smart contract can actually receive ether. So if I deploy this, compile, and I deploy, yeah, that means that I can send, here there is balance 0 ETH. So if I copy this address, I want to copy it, okay, I can copy it from here, and then I come here, so this is another address, and I click on this address, and so I think here there is I want to send ETH to this smart contract, or what I can do is okay, I think let me try to see if I can send. Fallback function is not defined. Okay, the call data should be valid. So let me put here 10 ether. 10 ether. Actually, yeah, so I'm going to put here 10 ether, and I deploy. So So I don't know how to send to this. Probably I can easily send to it if I deploy uh, on Etherscan. So browser extension, injected MetaMask, and then deploy. So I'm going to sign using my MetaMask. Okay. And so if we see here, balance is 0. So if I copy this address and send to it some ether, to this contract, amount is 0.00001. Okay. Confirmed. So you can see that this smart contract has the balance. And if you don't have the receive function, that means that your assets will get lost. Okay. So yeah, that's the use of payable. And so there are many other things that we can engage in, but I think they are a bit advanced. So probably with this information now we can create another smart contract. Or we should call it a day. So probably yeah, we can create something that is, yeah, with this we can stop from there, and we can now first look through the smart contracts that are developed. Maybe we can deploy this and verify. Let's see if we can verify. So deploy and verify. Confirm. Pending. And verification contract jacking experience for registration. Please input the API. Awaiting. So I think tomorrow we are going to start looking on Foundry as we also dive deeper into building smart contracts. There are very many other things we haven't looked at. Things like ABI encode, function selector, interfaces. Yeah. As this is confirming, probably look at there are things like sending ether, receive, fallback. We have looked at receive a bit. Okay, so some of the things we haven't looked at, I think we can also look at. So this is taking a long time to verify, but I think we can look at mappings and arrays, and then we close it from there. Let me first see this on Etherscan. So means it seems the verification is taking long. In the meantime, we can create a new contract. File. So some of the things we can look at include enums, structs, mappings, and arrays. So I'm going to be waiting for this to confirm SPDX license identifier. IT. So we are just going to look at this briefly, and yeah, we can start with arrays, I think. So the way we declare arrays in smart contract is like this. So one, you can have your array as long as you have this brackets, square brackets. So this is a dynamic array called R1. So you can have a static array maybe it's storing integers 256, and you give it values. Maybe I want 7. It's a public R2. You can also have 256. Where I initialize the values of the array. Okay, so here I'd forgotten. And the way we access an array is by index. So the starting value is always at index 0. The next is at index 1, next at index 2, the third is at index 3. So you can use the loops and things like that to access these values. You can always have a function to get, maybe get array data. I can pass in an index, so an index, and then since we are just going to read, it can be a public view and then returns this data. Returns a data of type uint 256. Or uint 256. So uint 256 data can be assigned to the variable I can read, the state variable, and then give it an array position, maybe array position 3. So 3 we shall always get 11. If that position is reset, or the default value will be 0. Yeah. So here we have we're going to return the data. Hello. Oh, it's supposed to be array 3, and then position I. So this position I is the position that a user will input. So we can also, maybe this can be array 1. Let's just use array 1. So if there is nothing in the array, we can always push to the array. So function push data. So uint. So we shall be accepting a value that the user will give. So their value. Most of the time, it's just a good convention to put an underscore to make sure that this variable is identified as local. So since we are going to be changing the state, can just leave public, and we say array1 dot push then the value that the user inputs. So this is supposed to be a value, and yeah, that's how we add. But deleting actually does not remove it removes the value, but does not remove the storage completely. Just resets it to 0. We can also just have it, so function pop data, I think that's it. So if I save this, getting an error, save it. So there is an issue in confirmation, and we shall look at this later. And if I deploy, I'm not going to verify, continue, yeah. Oh, I'm deploying on the blockchain, okay. View on BlockScout, view on Etherscan. Yeah, so the deployment has been successful. Here, if I call get data and I put in the index, which is the position, I'm expecting a 0 or nothing. And the reason why this is a very good error. So we are saying call to continue get array data error card, execution reverted, panic due to array range error 50, execution reverted, panic due to. So yeah, the reason why the execution reverted is because there is nothing in the array. So when I call the data at any given index, the array has nothing. So if I add something to the array using the push data, maybe I add some value 80 and I transact. Whenever you are changing the state of the blockchain, you are writing. So I expect my MetaMask to pop up. It has popped up, and then I transact. After transacting, it's pending, waiting for finality. And yeah, so the tick, that means that the transaction has been successful. The state has been changed. You can look at the block hash, you can look at the gas. We shall look at gas in detail. And now if I click here on position 0, so that means that now 80 will be in position 0 of the array. And I call, I can now receive a value. And if I put position 1 and I call, there is nothing. There is always a panic because there is no data in that position. And so let me add some data, maybe another data, and 20, transact. And wait. So yeah, so if I wanted to add another function, but let me just leave it at that. So when I call the get array data, I have to put in position 1, call it's 20. Okay, so you can always also get array.length to get the length of the array. So probably if you want to iterate over the values of array, function get magic number, get correspondent. So the issue is that if I change this smart contract, I have to redeploy it and deploy a new smart contract. So get correspondent, number. So we are accepting somebody to throw a number, and we give a bool whether it's true. U in 256. This is the guess. Public view returns. I'm going to return a boolean, and then we say for uint 256, I being assigned to 0, I less than. So I want to use the length, array3.length, array3.length. So the good thing is that we can view the state variables, then I plus plus. So we are iterating through the values of array3. So and we can say if guess is exactly equal to array3 I, so if it is exactly equal, shall have bool result will be true. So and then return result. Declaration error and declared identifier. So here I can declare a bool underscore result. So yeah, with this we can iterate over the array3 and see if we get a true or result. So it's like a guess game where somebody inputs their guess, and if it is part of the numbers in the array, then true is returned. So this is how functions are written. So array.length, all these things, yeah. Okay, so I think we've looked at arrays and We shall start from there to look at the mappings, structs, and enums. Unless you have questions or you want us to continue. It seems today has been a bit of a waking up call, stretching us a bit. But tomorrow we have a lot to cover. My intention is for us to at least build a product somewhere in the closest future, whereby we interact with smart contracts. So, and look at libraries like VM, Ethers.js, Windows.ethereum object, and see how we can use them to interact with the front ends. And perhaps maybe in the future we'll look at many more things as deemed fit. Otherwise, thank you so much for for being here. We should cover up on the okay. Have a great day. See us tomorrow. Yeah. You're most welcome.